Hello everyone, I Arpita Johari from the Department of Electronics and Communication Engineering is going to present the content on light emitting diodes, which is a type of special purpose diodes.
Today's lecture will be covered under the following heads. An introduction to optoelectronics, what is a LED, its constructional details, working principle, VI characteristics, their types, advantages and disadvantages, and their few applications. Let us discuss now about optoelectronics. Optoelectronics is basically a branch of electronics that deals with the conversion of electrical energy into light energy and vice versa with the help of semiconductors. Semiconductors are the materials whose conductivity lies in mid of conductors and insulators. As we can see in the following figure, laser diodes and LEDs are the types of light sources, whereas photodiodes and solar cells are the photodetectors. Moving on to LED, it is a semiconductor device that emits light when the electric current flows through it. LEDs are basically heavily doped PN junctions. Now, based on the semiconductor material used and the doping done, an LED will emit a colored light at a particular wavelength, and the condition applies that LED should be forward biased. As we can see here, a word doping is coming. Doping is the method of adding impurities into the semiconductors in order to improve its conductivity. LED structures are basically encapsulated with a transparent cover so that the emitted light can come out and be visible to our eyes. Here the symbol of LED is shown, where we can see that two arrows are being shown here, which tells that once the LED is forward biased, then the light would come out. Moving on to its construction, here we can see that it is a dome-like structure where LED has got two leads, anode and cathode. We can also observe that the cathode head is quite broader than the anode head. This is being done in order to maximize the emission of electrons. Greater the surface area, more will be the emission of electrons. Moving on to the constructional details. LED is encompassed with three semiconductor layers, which are N-type, P-type, and an active region. This active region or depletion region is sandwiched between N-type and P-type layers. When LED is forward biased, free electrons from N-type semiconductor and holes from the P-type semiconductor are pushed towards the active region. Here, inside the active region, both the charge carriers recombine, and after recombination, an invisible or visible light is being emitted. Moving on to the working principle. LEDs work on the principle of electroluminance, which is the property of the material to convert electrical energy into light energy, and later this light energy is being radiated. When an electron from higher energy band flows into the lower energy band, it releases its energy, which can be in the form of heat or light. If we talk about the basic semiconductor materials, which are silicon and germanium, then the electrons lose their energy in the form of heat. Therefore, these two materials are not being used as the LED constructional materials. Semiconductor compounds like gallium phosphide, gallium arsenic phosphide, They emit light when the electrons and holes recombine. The electrons in these compounds lose their energy by emitting photons. Then comes VI curves. As we can see that the current is being increased exponentially after a particular voltage, which is known as cut-in voltage. The color of LED is being determined by the band gap of the semiconductor and the forward voltage. As the current in the forward bias increases, the intensity of light also increases, but up to a maximum level. After this, once we are going to increase the current, the intensity of light decreases. Now the screen is showing various semiconductor compounds and the emitted radiation. For example, if we want to have a green light, then we are going to use the material gallium nitride. If we want to have a blue LED, then zinc selenide will be used. So depending upon the radiation we want, we will select the semiconductor material. Next comes the advantages and disadvantages. The basic advantages includes temperature range, where the LED can be operated over a wide range of temperature from 0 degree to 70 degrees Celsius. Switching time in LED is very less in the order of nanoseconds. Hence, they can be used in dynamic operations. LEDs consumes less power. Better controlling of LEDs can be done because the radiated power in LED is a function of the current flowing in it. They are cheaper and reliable. They comes in very small size and hence the portability increases. And as comparison to the standard tungsten lamp, their efficiency is 10 to 50 times higher. If we talk about disadvantages, then we need to take care of the voltage or current flowing through the LED because over voltage or over current may destroy it. Similarly, once the power is being radiated, then the overheating will also damage the LED. Now coming up to applications. LEDs are finding numerous applications in various fields, including optical communication, where they are used as light sources, alarm and security systems, remote controlled operations, robotics, etc. And the basic features due to which they are finding this humongous amount of applications are their long lasting capabilities, low power requirements, swift response time, and fast switching capabilities. So these advantages we have already discussed in the previous slides. So basically LEDs are used as a lighting source. They are used in motorcycles as well as cars. They are used in mobile phones, TV screens, display boards, glow boards, at traffic light signals, and many more. So in this lecture, we have covered the basics of LEDs, their working principle, constructional details, their advantages, disadvantages, and few applications. Thank you.